Hello everyone. In this lecture, I shall discuss the divergence and curl of vectors. If we recall the vector differential operator, here nabla or inverted del, what we read also del, operated on scalar and vector point functions lead to gradient, divergence and curl. If the field is a scalar field, then it leads to the gradient. Okay, but after operation this field becomes a vector field. F is a scalar point function, del is a vector, so now the grad f defines a vector field. Likewise the divergence defines a scalar field. Okay, it behaves like the dot product of two vectors is scalar. Curl, it defines a vector field, it behaves like the cross product of two vectors. Okay, now coming to the physical interpretation of gradient, divergence and curl, the gradient of a scalar field is a vector that points in the direction of greatest rate of change of the field. As I have told you, if we move to the top of the hill from the bottom, just looking into the top, it should be in the direction of the gradient. Okay, so now divergence of a vector field measures how much the field is spreading out, okay, or diverging from a point. That means divergence V gives the rate at which the fluid is originating at a point per unit volume, right? So it can be understood in the sense of spreading out or entering into, right? Spreading out from a source, entering into a sink. So in that case, spreading out means dive is positive, spread out. Entered into means converging, dive V is negative. And dive V is equal to 0 means the balance of outflow and inflow is 0. And in case of the incompressible fluid, okay, this dive V is equal to 0 is the equation of continuity, right? That means, roughly speaking, divergence measures the outflow minus inflow. Now coming to the curl of a vector, the curl of a vector field measures how much the vector field rotates. So curl means the rotational aspect of the vector, okay, or circulates about a given point. And later on we will see, that's why this curl is also known as rotation of V. So curl V is twice the angular velocity of this rotation. So I will discuss later on. Now before the details of discussion of the divergence and curl, let me to introduce myself. Myself Professor S.K. Paikray, Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, in short VSUT, Burla, Sambalpur, Odisha, India. Okay, so without much delay, let me to discuss the divergence, subsequently the curl. So coming to the definition, let V is equal to V1I plus V2J plus V3K be a vector point function. Vector point function. The divergence of V, denoted by div V, or I can write it del dot V, okay, or I can write it del V. So generally we do not keep vector on this del notation. If you keep it, then it's also okay. Is denoted by this, is given by div V is equal to summation of, or is equal to, you can write it I cap del by del x plus j cap del by del y plus k cap given by, here I cap del by del x means I am writing here div V is here del dot V. So del is here I cap del by del x plus j cap del by del y plus k cap del by del z. dot V. Okay, so in short I will write it. In short I write it summation of I dot del V by del X. Okay, del V by del X. Or if I write summation of J dot del V by del X, or I write summation of K dot del V by, it is del Y, del V by del Z. Okay, I write this means summation of I del V by del X means Y and Z are there. Okay, but if I want to write it in component form, here div V will be I del by del X plus J del by del Y plus K del by del Z, and here V is V1I plus V2J plus V3K. You know I dot I is 1, right? So this will be del V1 by del X. You know J dot J is 1, so it will be del V2 by del Y plus K dot K is 1, del V3 by del Z, and I dot J 0, I dot K 0, so other things will not exist, and this will be the outcome. So for the solving the problem, we use this aspect. Okay, for proving the properties we use this aspect. Okay, we use these aspects. So let me to give an example. Coming to an example, let here V is equal to 2x square yi plus 3yj plus 5k. Okay, if you are asked to find what is div V, means this is your V1, this is your V2, and this is your V3. Okay, so div V is del V1 by del X plus del V2 by del Y plus del V3 by del Z. So derivative of this with respect to X is 4xy plus derivative of this with respect to Y is 3, and it is your 0. So this is your 4xy plus 3. If it is asked div V at a point, suppose say 2 3 4, we just substitute the point here. Okay, so it is 4 into 2 into 3 plus 3, 28. So in that way it is 27. It is a 27. Now coming to the application of divergence. Here by saying the fluid, what we mean? By saying the fluid we mean it may be air, water, it may be gas, or it may be vapor. So this gas and vapor are compressible fluid. And this water means here incompressible fluid. So in application 1 I can say, if the fluid is incompressible, not able to compress, then there is no loss or gain in the volume, right? That means what? So this implies here div V is equal to 0, right? Div V is equal to 0. So this is known as the equation of continuity. In case of the incompressible fluid in hydrodynamics. And it is for the case of incompressible fluid. For compressible fluid it is different. It is for incompressible fluid. For compressible it is different. Now for compressible fluid, you note that here for compressible fluid, the equation of continuity is div rho V. Rho is the density of the fluid, plus del rho by del T is equal to 0. Now if the flow is steady, right? if the flow is steady, if the flow is steady independent of time, then this aspect will 0. Here div rho v is equal to 0 for steady state. Now the moment rho is equal to constant, okay, the moment rho is equal to constant, if rho equal to constant, then the fluid is, now the fluid is incompressible, fluid becomes incompressible. That's why here div v is equal to 0. So for incompressible fluid, div v is equal to 0. So here to conclude, I can say the flow of fluid with velocity v is incompressible if div v is equal to 0. So to conclude, I can say the flow of fluid, coming to another application to solenoidal field. So let F be a vector field. Then F is said to be solenoidal. If div F is equal to 0, everywhere in the field, right? Everywhere in the field. So now to repeat the applications of divergence, the flow of fluid with velocity v is said to be incompressible if div v is equal to 0, right? And for incompressible flow, the equation of continuity is div v is equal to 0, right? And for solenoidal field, vector field F is said to be solenoidal if div F is equal to 0 everywhere in the field. Next, coming to the curl. Now coming to the definition of the curl, let V is equal to V1I plus V2J plus V3K be a vector point function. Then the curl of V denoted by curl V, or we can write it del cross V, is given by here curl V is equal to del cross V is I cap del by del x plus j cap del by del y plus k cap del by del z cross V. So now you can write it, in short you can write it summation of I cap cross del V by del x, or you can write it summation of j cap cross del V by del y, or you can write summation k cross del V by del z. Means here this is operated on V, this is operated on V, this is operated on V, and vector I cross V, cross product of these two vectors. Okay, now if you think of it in the component form, right, we can write it in component form. Here curl V is equal to, here curl V is I cap del by del x plus j cap del by del y plus k cap del by del z, and it is V1I plus V2j plus V3k. So now it is simply the cross product of two vectors. We find the determinant I, j, k. It is del by del x, del by del y, del by del z, V1, V2, V3. We just evaluate this determinant to get the curl of the vector V. So now you note that curl measures the rotational aspects of V. That's why thus we can write curl of V, sometimes we write it rot V, rotation of V, right? And you see your curl V, right? Del cross V, it cannot be equal to V cross del, right? V cross del, though it is the cross product of two vectors, it behave like that, but it cannot be, because A cross B is not equal to B cross A, it is the negative of B cross A, right? So now we have a result relating the angular velocity and the curl. Now coming to an important result, if a rigid body in motion, then the curl of the linear velocity at any point gives the twice the angular velocity, means curl V is twice W, okay, angular velocity. So now to prove this, we should know some mathematical aspect of the vector. Coming to the scalar triple product A dot B cross C, you can write it A cross B dot C, right? And coming to the vector triple product, we can write A cross B cross C is equal to A dot C B minus A dot B C. You should note this, and we are going to use it throughout proving the properties. Now coming to the proof, let W be the angular velocity of the body moving about a fixed point, and R be the position vector of the any point P on the moving body, and with linear velocity V. From physics you know V is equal to W cross R. So now coming to curl of V is equal to del cross V, and is equal to, you write, summation of I cap cross del by del x of V. So this is summation of I cap cross del by del x, and V is your W cross R, okay. So that is equal to, you can write it, summation of I cross, so del is operated here, so it is W cross del R by del x, so W cross del. So now keeping the I component in view, we have I cross, it is W cross I, okay. Now coming to this vector triple product A cross B cross C, okay, so we can write it summation of A cross C, A dot C W minus summation of I dot W I. Here I dot I is 1 and I dot J I dot K 0, so the 2 will 0 here, so this is summation of W minus here W, only I will exist here, okay, minus W. So here it is summation of W along 3 direction I J K, it will give you 3W minus W, so this is 2W. So therefore curl of V is twice the angular velocity. And if we want to prove it in explicit way, alternatively if we want to prove it in explicit way, first we find, let, now in component form I take W is this, V, R is this. Now first I find V is W cross R. So what is my V? V is my W cross R. So this is equal to I, J, K, here W1, W2, W3, X, Y, Z determinant. If I simplify it, it will be W2Z minus W3YI minus J cap W1Z minus W3X plus K, here W1Y minus W2X, okay. Now if I find curl of V, so this will I, J, K, del by del X, del by del Y, del by del Z, and it will be here W2Z minus W3Y, it will be W1Z minus W3X, it will be W1y minus W2x determinant. If I simplify this determinant, it will give me I into this minus this, so it will give me I omega 1 plus omega 1, then it is plus j omega 1 plus omega 1, omega 2 plus omega 2, plus k omega 3 plus omega 3, okay, omega 3. So this will give you twice omega 1i plus omega 2j plus omega 3k. So this is equal to a twice w. Okay, therefore curl of v is twice the angular velocity. Okay, now coming to the properties and some applications. First, application of curl. So coming to the applications, as we see, curl v is the rotational aspect of v, is the rotation of v. I can write rotation of v. So now the moment if is irrotational, okay, if v is irrotational, if the body is irrotational, so if the body is irrotational, no rotation, irrotational, then what will happen? Then the angular velocity w is equal to 0, right? Angular velocity is equal to 0. So what does it mean? So this implies curl of v is equal to 0, right? Once the body is irrotational, then the angular velocity is 0. Angular velocity is 0 means your curl is here 0. So that means I can say the flow of fluid with velocity v is said to be irrotational if curl v is equal to 0, and in such case the field is said to be conservative. In such case the field is said to be conservative. So conservative field, what does it mean? That means the work done is independent of path. The work done is independent of path. The work done in moving from A to B, okay, from this point along any path is independent. That means it depends only upon the end point. It depends only upon the end point. Okay, end points. The path may be a circle, the path may be a straight line, the path may be parabolic. It is immaterial once it is a conservative field. Now coming to an irrotational field. What is an irrotational field? Like the solenoidal field for divergence case, a vector field V, or I can say F, a vector field F is said to be irrotational if curl F is equal to 0 everywhere in the field. Curl F is equal to 0 everywhere in the field. Curl F is equal to 0 everywhere in the field. Now coming to now recalling the applications. If curl V is equal to 0, then we say it is irrotational, and the field so created is conservative field. Conservative field means the work done in moving from point A to B along any path is same. It depends only upon the end point. Okay, so irrotational field means your curl F is equal to 0 everywhere in the field. Now coming to the applications, the properties of divergence and curl. Now before the discussion of the properties, let me to solve one example in the context of irrotational. Find the constants A, B and C such that the given field F is irrotational. Okay, So f is irrotational if curl f is equal to 0. So what is your curl f? Curl f is I j k del by del x del by del y del by del z. It is x plus 2y plus az. It is bx minus 3y minus z. It is 4x plus cy plus 2z. Determinant is equal to 0. It is for irrotational. Okay, so I simplified. It is I cap into partially differentiated with respect to y minus partially differentiated with respect to z. Okay, so it is differentiated with respect to y, it will give me c. Differentiated with respect to z, it will give me 1. And here minus j cap 4 minus a plus k cap b minus 2 is equal to here 0. 0 means I can write it 0i plus 0j plus 0k. So component wise I will compare. I component I compare, j component I compare, k component I compare. So this implies c minus 1 0, 4 minus a 0, b minus 2 equal to 0. So what does it mean? So that means here a is equal to 4, b is equal to 2 and c is equal to 1. In that way we will find. Okay, so if it is asked simply to find the curl f, then evaluate the determinant, and if it is asked that irrotational, then you show the determinant is 0. Now coming to the most important properties of divergence and curl. Now coming to the properties of divergence and curl, let us prove these properties. Proof 1, div fv. So this is equal to, you can write del dot fv. So this is equal to, in short we write summation of I cap dot del by del x fv. So we can write it. Now del is operated over here by applying the product formula. So this is equal to summation of I, it is f del v by del x plus del f by del x v. Now you separate them out. So this is equal to, you take f outside, it is summation of I dot del v by del x, and plus coming to this, it is summation of I del f by del x, taking v out. So this is equal to f, and this is your div v plus it is your grad f, and this is v. Okay, f div v plus v grad f. So this is proved. Coming to proof 2, your div of u cross v, so this is div u cross v. So this is equal to summation of I cap cross del by del x u cross v. It is a div, so it should be dot, okay, so that is equal. So now operating this here, so this is equal to summation of I dot, here the product formula here, del u by del x cross v plus u cross del v by del x. So now you separate the summation. So this is summation of I dot del u by del x cross v plus summation I dot, this is u cross del v by del x. Now you apply the formula here, a dot b cross c is equal to a cross b dot c. So you write it. So this is summation of I cross del u by del x v plus summation of I cross del v by del x u. So this is equal to, you can write curl u v plus curl v u. Coming to proof 3, it is curl of fv. So this is equal to del cross fv. So this is equal to summation of I cap cross del by del x fv. So you differentiate it. So this is equal to summation of I cap cross del f by del x u v plus f del v by del x. Now you can separate them. So this is summation of I cap cross del f by del x v plus summation of I cap cross f del v by del x. So by the property of the scalar triple product, you can write it summation of I cap dot del f by del x cross v plus summation of I cap cross del v by del x f, right? Because a cross b dot c is a dot b cross c, a dot b cross c, you can write it. Okay, so that is equal to, you have your curl f v plus curl v f. Now actually here f is a scalar here, so cross of this, so now it is, so now this v is a vector here, so cross will be here. Okay, so this property is applied over here, and this is f is simply a scalar, f is a scalar here, right? Now coming to the next property, now coming to proof for your curl u cross v. So this is del cross u cross v, that is equal to, you can write summation of I cap cross del by del x u cross v. Now product formula for differentiation keeping order intact. So this is equal to, you can write summation of I cap cross u del v by u cross del v by del x plus del u by del x cross v. Okay, so you now separate them. So this is equal to summation of I cap cross u cross del v by del x. Open the summation, it is summation of I cross del u by del x cross v. You can apply the formula here. A cross b cross c is equal to a dot c b minus a dot b dot c. You can apply this to the individual summations here. So this will be your I summation of I dot del v by del x and dot your u, this is your u, and plus this is again summation of I, it is minus, it is your minus, you see SCB minus ABC, ACB minus ABC, I dot u del v by del x. Now this term, coming to the second term, you have again here plus you can write it here summation of I dot v del u by del x minus summation of I dot del u by del x here v. Okay, now we apply this formula here. Now collect this first, then collect this second here, then third and fourth here, you collect in this way. So this is equal to here summation of, so you can write it here summation of I dot del v by del x, and v is u is here and minus it is coming to second term here, minus summation of I del u by del x, v is here, and put, and coming to third term, it is summation of I dot v, you can write also v dot I, a dot b is b dot a, del u by del x minus summation, you can write del u by del x dot I, and it is your v. So this is your, you can write it u dot I del v by del x. Now simplifying, you see this is nothing but div v, and this is my u, and this is nothing but div u, this is my v, and plus I can write it. This is my del. If I together with del by del x I take, then this is my v dot del, right? V dot del, and this is u, and this is my u dot del and remaining v. Okay, because u together with I del by del x, right, it will give me u dot del. So now it is proved. Now coming to the second order differential operator, here del square is del square by del x square plus del square by del y square plus del square by del z square. It is my second order differential operator. Okay, coming to most important properties, div of grad f, div of grad f. F is a scalar point function. Here we can say f is a scalar point function. F is scalar. U and V are vector point function, vectors. Okay, so here likewise curl of div of grad f, you can write del dot del f, right? This is equal to fxx plus fyy plus fzz. You can prove it. If you want to prove it, here del f, so this is equal to your I cap dot del by del x of grad f, and you know your grad f. What is your grad f? It is del by del x of grad f is fxi plus fyj plus fzk. Okay, so now you operate it. So this is summation of I cap, you operate dot, it is fxx i plus operate it fxy j plus operate it fxzk. Now here I dot I is 1, and this will 0, and this will give you 0, and this will also give you 0. So this is equal to I dot I1 summation of fxx. So what does it mean? It means fxx plus fyy plus fzz. Okay, alternatively you can write div of grad f is equal to your div of fxxi plus fyyj plus fzzk. Sorry, this is fxi fyj fzk. Okay, so now this is my v1, this is my v1, this is my v2, this is my v3. So this is del v1 by del x, so this is fxx plus del v2 by del y fyy plus fzz. Okay, so this, so now you note that here del square f. Okay, del square f, what we get? Del x fxx plus fyy plus fzz. Here div of grad f, we get it this. Now once this is equal to 0, once it is equal to 0, then we say f satisfies the Laplace equation, right? It's called the Laplace equation. It's called the Laplace equation. Laplace equation, right? That means your del square f is equal to 0. This is your Laplace equation. That means we say f satisfies the Laplace equation if del square f is equal to 0. Coming to another important proof, coming to another important property, div of curl of grad f is equal to 0. Curl of grad f is equal to 0, right? So let us prove it. So coming to the proof, curl of grad f, so this is equal to del cross your grad f means fxi plus fyj plus fzk. So by the properties, in short we are going to write summation of I cap cross del by del x of fxxi plus fyy, sorry, this is fxi plus fyj plus fzk. Now you operate this, so this will be your I cap summation of I cap cross fxxi plus fyyj plus fzzk. So f is a scalar here. So I can write it summation of I cross I fxx plus I cross j fyy plus I cross k fzz. So I can, this I cross I is here 0. So we can write it I cross j is k. So this is summation of k fyy plus I can write I cross k is minus j fzz. Okay. So if you open it, this is actually here fxy, this will fxy, and this will be here fxz. So this is xy, this is xz. So this is here xy. So this is equal to, you can write, this is equal to, you can write summation of I cross j is k fxy minus I cross k is j fxz. Okay. So now if you open it, when there is k it is xy, so you can write it I cap, it is x, it is yz, plus j cap, it is fxz, plus k cap, it is fxy. Now similarly if you open it, it will give you minus of, when there is I, it is when j, y is missing, when I, x is missing, fyz, j, y is missing, k, here z is missing. Okay. So now if you, it is here I fyz, yz, I fyz, then here j, then here k, this and this, k, so this and this, j and j cancel, then coming to here k and k also cancel here. So this is equal to 0. If you find this proof is difficult, the alternatively you can prove it like this: curl of grad f is equal to 0. So that means curl of grad f is fxi plus fyj plus fzk. So that is equal to, right, curl of this is equal to, you can write this. So this is equal to, curl means ij k del by del x del by del y del by del z, it is your fx, fy, fz. Then you find just the determinant. So this is I cap into fyz minus fyz minus j cap into fxz minus fxz plus k cap into, okay, fxy minus fxy. So this is cancelled, this is cancelled. So this is equal to 0. This is what also we see it here. This is what also we see it here. Pairwise cancelled. Okay. So now this is proved. This is proved. So you may adopt this method of proof also. Now coming to, and this, now this indicates your conservative field. Curl of grad f is equal to 0. This indicates the curl conservative field. Curl of grad f is equal to 0 means this is a conservative field. Right, conservative field. Now similarly, div of curl v is equal to 0. Right, this is another important property, and curl of grad f is equal to 0, important property. So coming to this div of curl f is equal to 0, let us prove it. Here div of curl v is equal to, you can write del dot, here curl v, you can write it del dot del cross v. So properties of divergence, you can write it summation of I cap dot del by del x of del cross v. So apply the differentiation rule here. So this is I cap del by del x of this you can write del by del x of, here del cross b you write in details, I cap cross del v by del x plus j cap cross del v by del y plus k cap cross del v by del z. Okay, so now you operate it. So this is equal to summation of I cap dot here I cap cross del square v by del x square plus j cap cross del square v by del x del y plus k cap cross del square v by del x del z. Okay, now you separate them out. So this is equal to summation of I dot I cross del square v by del x square plus summation of I dot j cross del square v by del x del y plus summation of I dot k cross del square v by del x del z. Now you have a dot b cross c is a cross b dot c. So that is equal to, you can write it, summation of I cross plus I cross I dot del square v by del x square plus summation of I cross j del square v by del x del y plus summation of I cross k del square v by del x del z. Now I cross I is 0 and I cross j is k and I cross k is minus j. So that is equal to, you write summation of k del square v by del x del y and minus summation of j del square v by del x del z. So when there is k, here z is missing, when there is j, y is missing, so we split it separately. So this is equal to, you can write I cap del square v by del y del z plus j cap del square v by del x del z plus k cap del square v by del x del y. So this is expanded. Likewise for this you have minus of I cap del square v by x is missing del y del z minus plus j cap del square v by y is missing del x del z plus k z is missing del square v by del x del z. So pairwise they cancel, that is equal to 0. Or alternatively, if I want to have the explicit proof, I can write it, let my v is equal to v1i plus v2j plus v3k. Now what is my call v? It is I, j, k del by del x, del by del y, del by del z, v1, v2, v3. Okay, so I split it. This is I into del v3 by del y minus del v2 by del z minus j into del v3 by del x minus del v1 by del z plus k into del v1 del v2 by del x minus del v1 by del y. Then you find div of call v. So this is my v1 say, this is my v2 say, this is my v3 say. I just del v1 by del x, I differentiate it with respect to x. So this is equal to del square v3 by del x del y minus del square v2 by del x del z minus del square v3 by del x del y plus del square v1 by del y del z plus del square v2 by del x del z minus del square v1 by del y del z. Now it is pairwise cancelled here, v3, v3, v2, v2, v1, v1. So this is equal to 0. Physically, what does this property mean? So what does it mean? The spreading out, this div, the spreading out of a rotational field, rotational vector field is 0, right? The spreading out of a vector that is also rotating is 0. Now coming to the last property. Now coming to the last proof. You have proof curl of curl V. So this curl of curl V I can write summation of I cap cross. I can write it explicitly. It is del by del x of, and this curl V I write it explicitly, I cap cross del V by del x plus j cap cross del V by del y plus k cap cross del V by del z. So now I operate it inside. So this is summation of I cap cross del square V by del x square plus j cap cross del square V by del x del y plus k cap cross del square V by del x del z. Now I operate. Now I separate them out. I cross this plus summation of I cross, it is j cross del square V by del x del y plus summation of I cap cross k cross del square V by del x del z. Okay, now I apply the property here. A cross B cross C is equal to A dot CB minus A dot B C. So I can use this property here. So this is equal to I can write I dot del square V by del x square dot I summation of and minus, this is ACB minus ABC, I dot del square V by del x square. So this is out of the first summation, and plus the second summation will give summation of I dot del square V by del x del y dot j minus I dot j del square V by del x del y, and likewise the third summation will give summation of I dot del square V by del x del z into your dot k minus I dot k, it is dot del square V by del x del z. So you see here I dot j0, I dot k0, only this will stand, and I combine these three here, this is equal to, you have here summation of I cap cross del square V by del x square I plus I cap dot del square V by del x del y j plus I cap dot del square V by del x del z k, right, and it is minus I dot I is 1, summation of del square V by del x square, right. Now I claim that this is my grad of dive V, okay, and this is my del square V, your del square V, okay. So now you claim this. To justify our claim, we have dive of grad of dive F, dive V. So grad is summation of I del by del x, and your dive V is I cap dot del V by del x plus j cap dot del V by del y plus k cap dot del V by del z. Now I operate it. So this is equal to summation of I, it is I dot del square V by del x square plus j dot del square V by del x del y plus k dot del square V by del x del z. Okay, now just I split it. So this is equal to, I can write summation of I dot del square V by del x square I plus I dot del square V by del x del y j plus I dot del square V by del x del z k. Okay, so now A dot B dot C is A dot B dot C in any order I write. So now I substitute in star. So let it be my star. So now star follows. Now star follows curl V, and I get the first term as my grad of div V, and the second term is my summation of del square by del x square. So this is my del square V by del x square plus del square V by del y square plus del square V by del z square. So is it not my grad of div V minus my del square V? So this is proved. So to conclude, in this lecture we have discussed the divergence and curl. Divergence of V defines the solenoidal field and curl of V defines the irrotational field, and we have proved so many important properties. The properties of second order properties are very important, so you should carefully see all these properties. To prove these properties, you have to know the rule of the vector, the scalar triple product, the vector triple product, and accordingly you should see the details as we did. So if you feel this lecture is helpful for you and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lecture for your benefits. So thank you all. Have a nice day.